Hello, welcome to Guidancee Education channel. We are starting a new chapter under class 12 Physics. Chapter 1 Electric Charges and Fields. Let us see the topics discussed in this video. The topics covered are Coulomb's law, definition, mathematical expression, and 5 questions answered. This video will be of great use to you. Therefore, watch the video completely without skipping. Anyway, I have given the time schedule for the various topics in the description box below. Please like the video, share the video with your friends who may also be benefited, and also leave your comments in the comment box below. If you have not subscribed my channel, do subscribe now and also press the bell button so that you get intimated as soon as videos are posted. Thank you. The chapter is on electric charges and their fields. By fields we mean the area where its influence is experienced. Here, electric charges are static, that is, they are not moving. Let us suppose this is one charge. Let us name it as Q1. This is yet another charge. This is Q2. The charges are point charges. If the size of the charges is much less than the distance between them, then such charges are called point charges. Point charge does not mean they are single charges. Each point charge may contain several charges. Any object will have positive and negative charges in them. If the positive and negative charges are equal, they are neutral. While charging an object, if the object gains electrons, it becomes negative. If it loses electrons, it becomes positive. We shall discuss this later when we discuss quantization of charges, a property of electric charge. Let the distance between the two charges be equal to r. Coulomb studied the nature of the force between static electric charges. Static means not moving, that is, they are stationary. They remain at the location where they are. This law is a quantitative statement of the force between charges. It gives the magnitude of the electrostatic force between the electric charges, which are stationary. According to Coulomb's law, the electrostatic force is directly proportional to the product of the two charges, that is, F is directly proportional to Q1, Q2. How do you find the magnitude of Q1 and Q2? Magnitude of one charge into total number of charges present in Q1. That will be the magnitude of Q1. Similarly for Q2. According to the law, F is also inversely proportional to the square of the distance between the two charges. We have taken the distance as r. On combining these two, we get the expression F is directly proportional to Q1 Q2 by r square. Using a proportionality constant equal to k, F is equal to k into Q1 Q2 by r square. The proportionality constant k is mathematically represented as 1 by 4 pi epsilon naught. Epsilon naught is the permittivity of free space. Magnitude of k is equal to 9 into 10 raised to 9 Newton. It is force. K can be defined as the force between 2 point charges of 1 coulomb each. Coulomb is a unit of charge separated by a distance of 1 kilometer. So this equation can be written as F is equal to 1 by 4 pi epsilon naught Q1 Q2 by r square. This is the mathematical representation of Coulomb's law. So it is very simple. Now we will note down the Coulomb's law statement, that is definition of Coulomb's law. It states that if 2 point charges are kept separated by a distance in space, the force between these two charges will be directly proportional to the product of the charges and inversely to the square of the distance between them. I hope these points are quite clear. The mathematical expression of this law gives only the magnitude. Force, you know, is a vector quantity, so it does not give the direction of the force. In order to understand the direction in which the force is acting, we have to use the vector form. We shall do that in the next video. Now we will do some important questions related to this topic. I have provided 5 questions here. We will do one by one. First question. State the important properties of electric charges. Answer. Charges are additive. That is, they can be added like mass. But here we have to consider their signs. There are positive as well as negative charges. The second property is conservation of charge. That is, charges can neither be created nor destroyed. The third one is quantization of charge. Second question. Find the charge Q on a system containing the following charges: plus Q1, minus 2Q2, minus 4Q3, plus 5Q4. By the principle of additive property, we add up all these charges. Positive Q1 plus positive 5Q4 is equal to positive 6Q. Negative 2Q plus negative 4Q is negative 6Q. Equal number of positive and negative charges get cancelled. So charge on the system is 0. Third question A. What is quantization of charge? Quantization is the property of charge by which all free charges are integral multiples of a basic unit charge of an electron or proton represented by the letter E. For electron it is E negative and for proton it is E positive. Integral multiple means whole number multiple, that is not a fraction. Section B. What is the reason for this? The reason for quantization of charge is that while charging an object, only integral number of electrons can be transferred. What does this mean? When a body is charged, only whole number, integral number of electrons, 1, 2, 10, 5, etc. Such numbers only can be transferred, that is either received or donated, thereby acquiring negative or positive charge respectively. There is one more sub-question C. Q, the charge on a body, is NE. N is the number of charge and E is the magnitude of the charge. Now the question, say whether a charge equal to 5.8 into 10 raised to minus 18 Coulomb is possible. Using the formula, we can find out the number of charges in 5.8 into 10 raised to minus 18 Coulomb. N is equal to Q by E. That is equal to 5.8 into 10 raised to minus 18 divided by 1.6 into 10 raised to minus 19. On simplification, the value we get is 36.25. It is a fraction. As per principle of quantization or the property of quantization of charge, fractions of charges cannot be transferred. So a body cannot have a charge of 5.8 into 10 raised to minus 18 Coulomb. This value is not possible. Next question, that is question number 4. There are two sections there. What is the SI unit of charge? The answer is Coulomb. It is represented by the letter capital C. Next section under 4. How many electrons are there in one Coulomb charge? We know the charge on one electron. It is equal to 1.6 into 10 raised to minus 19 Coulomb. Number of electrons in one Coulomb charge is equal to 1 Coulomb divided by 1.6 into 10 raised to minus 19 Coulomb, which can be written as 1 Coulomb by 1.6 into 10 raised to 19 Coulomb. Coulomb and Coulomb will get cancelled. I am sorry, I have missed Coulomb in the numerator. Anyway, the number will be equal to 6.25 into 10 raised to 18. So, 1 Coulomb of charge will contain 6.25 into 10 raised to 18 electrons. Question number 5. Illustrate conservation of charge with an example. I shall accommodate the answer in the available space itself. In radioactive decay, one neutron may undergo destruction, that is, it might get destroyed and produce one electron with negative charge and one proton with positive charge. The charge only is represented here. I have used small letter n to represent neutron. The charge on neutron is 0. It has no charge, it is neutral. The value on left hand side is 0. On the right hand side, minus 1 plus 1 becomes 0. So the total charge before and after the decay is the same, equal to 0. So charge is neither created nor destroyed. This example illustrates conservation of charge. I hope this video was of great use to you. Subscribe my channel if you have not yet done so. We will meet in the next video with vector form of Coulomb's law. Thank you very much.